Okay, today's notes will be on 15.4, solving right triangles. So when you are asked to solve a right triangle, what that means that you need to do, it means you need to find all missing angles and sides. All right, so they're going to give you just enough information that you need so that you could complete the triangle. All right, so there will be multiple steps to each problem when you have to find multiple different things. All right, so keep that in mind. All right, so we'll do a few examples here. So our directions, we will solve the triangle for right triangle ABC, where C is the right angle. All right, some of your problems that you'll see in your homework today, they'll have the triangle sketched for you, and you'll see where the side lengths are and where the angles are. Others, they're going to tell you it's triangle ABC, and they always tell you C is the right angle. So then you have to sketch it correctly, otherwise you're going to get it wrong. So I want to make sure that we look at problems where you would have to sketch the triangle from the information they are giving you. Okay? So my first example, angle A equals 35 degrees. And then this is little c equals 12.7 inches. All right, so capital letters are used for angles, and then your lowercase letters would be used for the side lengths corresponding across from that angle. So when I go to sketch this triangle, they already told me it's a right triangle. All right, so that's angle C. The side length across from the right triangle needs to be little c, and that's in inches. It doesn't really matter where I put A and B as angles, but wherever I choose to put large A, little a would be directly across or opposite from that, and then wherever I put B, little b would be directly across from that. All right, so that would be an example for sketching this triangle. The other information they tell me is angle A is 34 degrees. Okay, so in Math Excel, it's going to have you find each piece. All right, it's typically going to have you find the next piece that would make the most sense to figure out, like angle B. Find angle B, and then they'll leave that blank for you. All right, since we know this is 90 degrees, angle A is 34 degrees. So I need to figure out what's remaining then from 180, or if I have 90 degrees, then these two angles have to add up to 90. So I can either add 90 plus 34, take that away from 180, or take 90 minus 34 degrees. Okay, and that would give me my angle B. So 56 degrees. Okay, I can fill that back in here. I can use that angle if I want to find other information. What's nice in Math Excel is you type that in and you check your answer and they'll tell you that it's right, so then you know you could use it. But if I was working through a whole problem where I can't check those little pieces, I always tell students use the angle that's given because you know that's correct. In case I made a little bit of an error and then I use that angle for something else, I'm going to keep creating things that are wrong. Okay? All right, so the things we need to find would be side A and side B. So the order that you find them doesn't really matter. Just make sure that you're checking Math Excel when it asks you for which one to find, that you're typing it in the correct spot. All right, I don't want you doing all your math correct, but then you're not paying attention to what they're asking for. So if I look at side A first, all right, and I want to find this, I need to set up an equation to find that. Things that I know would be this angle, and I need to think about the relationship between this angle and side A would be opposite, right? And the other side length I know is 12.7, and that is my hypotenuse. So I can set up an equation that would use the opposite side and the hypotenuse. So that means I would use the trig function sine. Okay, so I'm going to take sine of 34 degrees, and that would have to be equal to the opposite side, which is A, what I'm trying to figure out, over my hypotenuse, which is 12.7. All right, this is similar to what we've done, but typically we never have the angle. We just write sine of theta equals 1 over 2 or something like that. Okay, now we have the angle, so we include what the angle is, and here's my variable. Typically, the angle is my variable. Okay, a lot of times I have students that do not write sine and cosine with an angle, so they don't understand that it always has to have an angle next to it, otherwise there's nothing to do with it. Okay, so if I was going to solve this and get A by itself, I'd go ahead and multiply by 12.7 to undo on that side, and then multiply sine of 34 degrees by 12.7. All right, so we'll need to use our calculators again today. Make sure you're still in degree mode from yesterday on your calculators. You can type this all in at once if you would like, but make sure you put your 12.7 in front of sine of 34 degrees, and then you can press enter. You can definitely find sine of 34 degrees first, press enter, and then multiply by 12.7. A lot of your calculators will put parentheses around this, and if you do not close those parentheses and then multiply by 12.7, if you do it in that order, it will do it wrong. All right, if I don't close those parentheses, it's going to multiply 34 and 12.7 as the angle and then take sine. Okay, so either find sine of 34 first, multiply by 12.7, or just put it in front if you're worried about not closing parentheses when you need to. All right, so if we check that answer, little a would be 7.10 is what I had, but check and make sure you are putting the amount of decimals that they want you to in Math Excel. All right, so that was side A, 7.1 inches. Okay, I haven't solved this triangle yet. I still need side B. At this point, you definitely could do the Pythagorean theorem to come up with side B. That would be fine. My only caution to you is if 7.1 was wrong and you use 7.1 in the Pythagorean theorem, then side B will be wrong. Okay, so just careful about that. So I'm going to go ahead and set up another trig function equation just to kind of practice that and show you that you could use something else if you didn't want to do Pythagorean theorem. Okay, so if I'm looking for side B this time, all right, let's say I'm still only focusing on this angle here. So now I have the adjacent side for 34 degrees because B is next to it. And then if I use the thing that's been given is my hypotenuse, right? Oh, I was going to put hypotenuse. So my adjacent side and my hypotenuse would use cosine. So I can set up an equation of cosine of 34 degrees would equal my side B over the hypotenuse of this triangle. Okay. Probably the most common problems I've seen on practice tests for ACT are problems where you are solving for side lengths and solving for angles like this. Okay, and setting up these equations. All right, so this I do the same thing, multiply by 12.7, undo it, multiply this by 12.7. So in your calculator, you can type that in all at once. I would just suggest to put the 12.7 in front. And then that should come out to be 10.53 is what I rounded to. okay? And that would be one problem for us. So like you can tell, there are multiple steps, kind of takes a while to do one problem, okay? All right, I'm going to set up another example like this. So our second example, so I'm going to give you angle A is 31 degrees. Side A would be 35.9 kilometers. So we'll go ahead, set this up, we'll sketch the triangle, and then we'll find those missing sides. So same thing, angle C is going to be a right angle. So little c is the hypotenuse. I'll set my A and my B in the same spots as I did last time, just for consistency. Once again, I gave you angle A. You know side A, which would be across from angle A, and then we don't know little b. So very similar to the last problem, but our equations will be a little bit different in how we solve them. MathXL, again, will probably ask you for angle B first, and then I'll ask you for the sides after that. All right, so those are all the things that we need to find before we are done solving our right triangle. For angle B, so we've got our 90 degrees. I've got 31 degrees. I need to figure out what's left over for 180 degrees to make the sum of the angles in this triangle. Or if I take 180 minus 90, I'm left with 90. So if I do 90 minus 31, that will come up with my angle B. So 59 degrees. Okay, you can fill that in if you would like. You can use that as an angle in setting up your other equations for finding sides B and C. But if you made any error in coming up with that angle, it would cause errors throughout the rest of your problem. Okay, so up to you. I'm going to go ahead and just use the one that's given to me just in case. Okay, but we know we're right now. All right, so I've got, let's look at side B first. Here's side B. That would be adjacent to angle A. I did not give the hypotenuse this time. I gave a side that would be opposite to angle A. Okay, so I'm using opposite and adjacent. So the trig function I would use would be tangent. So tangent of 31 degrees would equal, my opposite side is 35.9 divided by my adjacent side, which is B. All right, so I wanted to make sure we did an example like this because in our last problem, our variable was always in the numerator and we just multiplied by that denominator. So sometimes I have students that will struggle with solving when it's in the denominator. So a couple different things you can do. You can treat this like a little bit like a proportion cross multiplication type of problem, right? I can take 1 times my 35.9 and then B times my tangent of 31 degrees and then divide by my tangent of 31 degrees. That's fine. I typically think of it as I'm going to multiply both sides by B to get B out of the denominator. And then from here, I'm going to divide by tangent of 31. So what I'm typing in my calculator is 35.9 divided by tangent of 31 degrees. Okay, whether you're thinking of it like a cross multiplication problem, you're going to get the same result either way. And then check your results here on your calculator. So side B, I had written down was 59.75. And we're in kilometers. Okay. If you have both those side lengths and you're confident they are correct, you can go ahead and use Pythagorean theorem to come up with your hypotenuse C. That's fine. I'm going to go ahead and practice setting up one more trig function just to get used to that. All right, so if I went off of angle A again, I'm looking for the hypotenuse this time. What was given to me was the opposite side, so if I only use what's given, then I would have chosen to use sine of 31 degrees would equal my opposite side, 35.9, over my hypotenuse, which right now is. So it looked very similar in the way that we set up to solve for side B. I can go ahead and multiply each side by C and this side by C. So to get C alone, I will take 35.9 and divide by sine of 31. And that will give me my side C. When you get used to setting these up, for me, I'm faster at putting that in my calculator than I am with the Pythagorean theorem. Okay, so that is one pro I see, but some students take longer to kind of figure out which side length and all that. So some students would prefer Pythagorean theorem. It is up to you. But side length C, I had written down as 69.70 kilometers. Okay. All right. I know these problems do take some time. I do want to show you another type of example because it's going to be a little bit different. So I'm going to give you little side A, 18.9 centimeters, and little side C, 46.3 centimeters. So I did not give any angles this time. So draw a little sketch, my right triangle. C is my right angle. We know little c is 46.3. Doesn't matter where I choose to put my A and B. I'll just keep it consistent. So that means little a would have to be across from large A, and then this would be little b. Okay. So typically, MathXL will probably ask you to come up with side B first. Because you're given those two side lengths now, I would for sure use Pythagorean theorem because I can't do anything else without knowing the other two angles. Okay. You're probably fairly confident with that. I'm just going to write the work down here for coming up with that, but I'm pretty sure we're all okay with Pythagorean theorem, and you could solve find B. I'll give you that answer so we can move on to the part that you may be a little bit newer to you. Okay. All right, so we need to find angle A and angle B. Okay. I'm still going to set up an equation. So if I'm setting up an equation to find angle A, I need to look at what do I know? All right, I know the side that is opposite to angle A and the hypotenuse. So I need to think about, well, what uses opposite and hypotenuse? Well, that would be sine. So sine of angle A would equal the opposite side over the hypotenuse. Okay, so this is like a problem that we would have did yesterday, but you were given things more like sine of theta equals 0.5625. Find theta. And what did we have to use? We had to use inverse sine to find the angle. Okay, so this is same concept. So I'll use the inverse sine button, and then I'm putting in the 18.9 divided by 46.3 to find the angle for sine. So then the angle for angle A would have been 24. I have 0.09 degrees. Once again, make sure you pay attention to what they ask you for in Math Excel. I can't remember how many decimal places they want, usually more than I ask for. Okay. Then you can go ahead, if you do have that angle, you could set up another trig function, but it would be a lot quicker to just take 90 degrees minus your 24.09 to come up with angle B. So 65.91 degrees. Okay, so that's about as different as it's going to get. You might be given side lengths and have to find angles and use the Pythagorean theorem. You might be given an angle with a side, and then you need to use those trig functions to solve for those side lengths. But that's about all that you will see. We will have a couple word problems on there, so I want to do a couple examples of word problems. The best part with the word problems is typically you only need to find one thing. So they should be faster in that sense, but you got to set them up. All right, so we'll do 2 application problems, and then we are done with these notes today. All right, so Shelley stands 123 feet from the base of a flagpole. The angle of elevation, we'll talk about what that means, to the top of the flagpole is 26 degrees. Her eyes are 5 feet above the ground. That's our situation. What we need to figure out is we need to find the height of the flagpole. All right, some cases they're going to give you a word problem and they'll give you a picture of it so you can kind of see what's happening. Other times they're going to expect you to kind of sketch this picture and figure out what's happening yourself. Okay, I'm going to make us sketch both of them because I think that's harder, but you will have some where you would not have to do a sketch. All right, so you can put Shelley wherever you want here. And it's talking about the height where her eyes are. So I put like the bottom from her to this flagpole is 123 feet. That was given to me here. Then we have, so here's our flag. Now you can draw a flag if you want. So I'm creating my right triangle here. I've got my right angle. What else did they give me? Her eyes would be 5 feet. So this right here is 5 feet. Am I missing anything else? Nope, that would be it. So I want the height of the flagpole. So I'm going to find this, but when I find that, it's just going to be that portion, and then I'll have to add on that extra 5 feet at the end, is all that will be. Okay? Oh yeah, it gave me the angle of elevation. So your angle of elevation is always the angle from where you're at to where you're looking up. Okay, so it'll give you an angle of elevation, or it'll ask to find an angle of elevation. So wherever the person or thing is, they look up to something, so she's looking up to the flag, that will be 26 degrees. Okay, so I don't know the side that is opposite to the angle that I do know. The other part that's been given to me is the 123 feet, which is adjacent to the angle that I'm given. So what would use opposite and adjacent? Tangent. So that means tangent of 26 degrees would be the side I'm looking for, x, over the side that I know, 123. And then we want x. So this would be the case where I'm just going to end up multiplying 123 times tangent of 26 degrees to come up with my answer. I had 59.99. I don't remember what other decimals they were after this, but I stopped there. That's going to give me x, but then the true height would be 59.99 plus the 5 feet off the ground for her eye level. So that'd be 64.99. Okay. I thought I had a problem on Math Excel that was similar to that one, so make sure you double check that so that you wouldn't enter in the answer 59.99, do all the work, and you really did it correct, but you missed this little piece. Okay. I've got one last example I want to do, and then we'll be done. It's a bit of a longer lesson. Hopefully you're bearing with me. All right, last one. So the length of a shadow of a building (34 meters tall) is 37 meters. Find the angle of elevation. Of the sun. All right, so if we do a quick sketch of this right triangle, and you put your sun somewhere, all right, if you wanted to draw in the sun, you're looking up to the sun. So this is the angle they want. That's the angle of elevation, looking up to the sun. If we put your building is 34 meters. Oh, wait, just a second. The length of the shadow, so your shadow will be on the ground. Right, the length of the shadow is 34, and the building is 37 meters tall. All right, I don't know this missing angle. Call it whatever you want. Theta is our favorite variable for angles, so we can go with that. All right, then I need to take a look. So I don't have the angle, but I need to figure out which trig function would I use based on the information I'm given. So I've been given the opposite side, and I've been given the adjacent side to my angle theta. So opposite and adjacent would use tangent. So tangent of theta would equal, the opposite side is 37, the adjacent side is 34. If I'm calculating theta, I need to use inverse tangent of my ratio. All right, if you type that in your calculator, you should get about 42.58 degrees. If you notice on both of our word problems, we use tangent as the trig function. That's pretty common in a word problem. If you think about it, You typically have measurements of heights and a length, but this is typically an imaginary thing, right? The hypotenuse is just a line drawn in between those to complete the right triangle. Most of the time you would not have the length from a person to the sun, okay? So that's very typical, is to use tangent in more realistic situations. All right, that is it for our notes today. A bit on the longer side. Your homework will take a little bit more time than it probably did yesterday. No new assignment tomorrow. Just reviewing. Good luck. Bye.